Hello and welcome to this Academy Cloud Foundations demonstration. In this particular segment, we will be speaking about Amazon Simple Storage Service, or Amazon S3 for short. Amazon S3 is an object storage built to store and retrieve any amount of data from anywhere on the internet. It's a simple storage service that offers an extremely durable, highly available, and infinitely scalable data storage infrastructure at very low cost. S3 provides a simple web interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. Using this web service, you can easily build applications that make use of the internet storage. And since S3 is highly scalable, you only pay for what you use. You can start small and grow your application as you wish. You get no compromise on performance or reliability. S3 is also designed to be highly flexible. You can store any type and amount of data that you want. You can read the same piece of data a million times or only for emergencies like disaster recovery. You can build a simple FTP application or a sophisticated web application like Amazon.com, the retail website. So S3 frees you as a developer to focus on innovation instead of figuring out how to store your data. So how do we get started? You need to have an Amazon Web Services account to access S3. I have here my Amazon account. I'm going to be navigating to the S3 console. We get to see that it's a relatively simple console with just a few items actually worth highlighting. The very first one is that the S3 console gives you a global view of all of your buckets. Despite the fact that a bucket actually needs to live in a particular region, the console provides you a global overview of all of the buckets existing, including the region in which they live. Notice this one on US Oregon, most of them on North Virginia. And as you may have noticed, a bucket happens to be the logical storage resource for Amazon S3. In order for us to create a bucket, we click on the Create Bucket button. A bucket needs to have a name that is DNS compliant. What this means is that in general, you want to focus on using lowercase letters, numbers, and dashes, and not make the name too big. The reason for this DNS compliance requirement is that the name of the bucket will actually be used on the URL that you use to access your files and your objects, and therefore it needs to be unique globally. If you forget the uniqueness of the name, or if you're not sure if the name is being used, the system itself gives you a heads up when a particular bucket name is already in use. Let's take the example for the bucket name test. That is a relatively common actual bucket name. If we click on create, you get to see the system tells you the bucket name already exists. Therefore, we need to apply some form of change to this particular name in order to be able to use it. Notice also the little I to the right, which kind of reminds you that the bucket name needs to be unique across all buckets in the system globally. And this has to do with the fact that the bucket name is being used in the URLs that then will access the bucket as well as the objects within it. Now, let's take this other example. In this particular case, the bucket name may not be in use. However, we're using uppercase letters, and the system makes an attempt to remind you of what is allowable versus what cannot be used. I'm going to name this particular bucket ACF S3 Demo. This appears to be a unique enough bucket. I'm choosing to store it in the Sao Paulo region as a way of putting it as far away from where I am as possible. Which region do you actually choose in order to put a bucket can follow a number of requirements. You can also choose a region that is remote from your other operations for geographic redundancy and disaster recovery purposes. You can choose a region that enables you to address specific legal or regulation requirements. And finally, you can choose a region that allows you to reduce storage cost. You can choose a lower price region to save money. In this case, I'm just using Sao Paulo for demonstration purposes. Now, I can choose the Create button immediately, but let's explore what kind of questions the user interface gives us as we manufacture a bucket. I'm going to click on next. And we get to see a number of other properties that can be attributed to this particular bucket. We get to see on the top versioning, which basically keeps all the versions of a particular object on the same bucket. When you enable versioning, multiple uploads of the same file are actually retained by a timestamp. And that actually helps you be able to recover for accidental overwrites or deletion. Enabling versioning also increases the total data size that is stored in your bucket. So you need to be mindful of that, especially when it comes to billing and pricing. We see also the item for server access logging. And this is a way of maintaining a trace of the type of access that a particular bucket is actually sustaining. Tags represent key value pairs that you can use as a way of providing kind of stickers to be able to align the use of the bucket in terms of perhaps who is the owner, who the contact person is, for what purpose is this bucket being used. Object level logging, as the name suggests, is actually a trace file that keeps a record of who is accessing objects in this particular bucket. CloudTrail will be able to maintain such items. One important item about S3 is that you can enable encryption. Encryption in S3 uses AES 256 encryption, and you have a variety of ways of managing the keys that will cipher this particular item. You can have the S3 service manage the keys itself. You can manage the keys yourself as a customer, or perhaps you may want to leverage the AWS service for key management. In that particular case, you get the freedom to choose how the keys are handled. Last but not least, you can actually have CloudWatch request metrics for the usage of this particular bucket. In this example, we're leaving everything as default. The next item has to do with permissions. And following the principle of least privilege, and as it is common with most of AWS resources, basically public access to the resources that you create is sealed shut. Unless you specifically enable access to a resource, only the owner will be able to access and manipulate these items. Notice how the block all public access is enabled. We're going to leave it as is and continue to move forward. In this panel, we are reviewing the configuration, the name of the bucket, the region, the options, as well as the permissions that have been enabled by default. We're taking it as it shows up out of the box. We're going to be creating the bucket. And now we get to see ACF S3 demo bucket. If we navigate into it, you are able to examine, number one, the region in which it lives, and the properties for the bucket can actually be modified through the Properties tab. The permissions for the bucket has its own tab, allowing you to be able to block or enable public access. You can assign a bucket policy. This will be created using the Identity and Access Management Service. You can also define an access control list. This is a legacy mechanism that actually existed prior to policies being able to be used. The Management tab allows you to be able to define lifecycle for the objects in this bucket, allows you to define perhaps analytics in terms of usage for this particular bucket. Going back to the overview, we are within the bucket and we're going to upload a particular file. Notice also the button for create folder. A folder is actually an abstract concept in the idea of a bucket. It's not really a folder the way that we got to know it using an operating system, despite the fact that the S3 interface actually presents it like that. It's basically a logical separator for you to be able to organize files within a bucket and still follow a particular hierarchy. We're not going to create a folder. However, we are going to upload a file. When we select the upload file, we click on Add Files. I navigate to my desktop, and I'm going to select my machine profile application. This is packaged in Mac format. Notice how it already registered the name. I'm going to click on Next as a way of demonstrating how, for that particular object, I am the owner. I can read, write, and modify. You can add another AWS account to have access to this. We're going to leave that as is. And notice how in terms of public permissions, as we mentioned earlier, public access is blocked. As most things AWS, public access out of the box is sealed shut. Unless you specifically enable access, access will be disallowed for anyone but the owner. Clicking on next, select the storage class for this particular object. And as you get to see, there is a significant amount of storage classes. Each of them actually has its own use and applicability for use cases. The standard storage class is usually the default storage for any uploads that you have. This is the more common item and is intended for frequently accessed data. Notice in the availability zone, it indicates that at least 3 availability zones are actually at play when you upload the object. And this is how S3 is able to implement high availability, high durability. Each object as you upload it actually gets copied into 3 separate availability zones, and 3 copies of this particular item exist at all times. In the event of a failure on a particular facility, you always have redundant copies that actually become available to you. Now, interestingly enough, the second is the intelligent tier. As the name suggests, this is for long-lived data with changing or unknown access pattern. So Amazon S3 intelligent tiering is an S3 storage class for data with unknown access patterns or changing access patterns that are difficult to learn. It is the first cloud storage class that delivers automatic cost savings by moving objects between 2 access tiers when access patterns change. One tier is optimized for frequent access, and the other lower cost tiers are designed for infrequent access. Objects uploaded or transitioned to S3 intelligent tiering are automatically stored in the frequent access tier. S3 intelligent tiering works by monitoring access patterns and then moving the objects that have not been accessed in 30 consecutive days to the infrequent access tier. If the objects are accessed later, S3 intelligent tiering moves the object back to the frequent access tiers. This means that all objects stored in S3 intelligent tiering are always available when needed. There are no retrieval fees, so you won't see unexpected increases in storage bills when access patterns change. So S3 intelligent tiering is for data where you don't really know the access patterns or whether they're changing and you cannot really discern them. So it is ideal for data sets where you may not be able to anticipate what the access pattern is going to be. It's all about saving you money and maintaining the object in the proper tier. S3 standard infrequent access is Amazon's S3 storage class for data that is accessed less frequently but requires rapid access when needed. S3 standard IA, as it is called, offers the high durability, throughput, and low latency of Amazon S3 standard storage class. It also provides you a low per gigabyte storage price and per gigabyte retrieval fee. So this combination of low cost and high performance makes S3 standard IA ideal for long-term storage, backups, and as a data store for disaster recovery. The S3 standard IA storage class is set at the object level and can exist in the same bucket as the S3 standard or S3 one zone IA storage classes. This will allow you to use the S3 lifecycle policies to automatically transition objects between storage classes without any application changes. This particular storage category is also used by the intelligent tier. S3 one zone IA storage class is an Amazon S3 storage class that customers can choose to store objects in a single availability zone. S3 one zone IA storage redundantly stores data within that single availability zone to deliver storage at 20% less cost than geographically redundant S3 standard IA or S3 standard, which stores data redundantly across multiple geographically separated availability zones. S3 one zone IA offers 99% availability. But unlike the S3 standard and S3 standard IA storage classes, data stored in S3 one zone IA will be lost in the event of an availability zone destruction. So you need to be able to reproduce the data that is stored in S3 one zone IA. This is usually thumbnail pictures from a high resolution picture catalog, or data that normally lives in its natural form someplace else, and you use the S3 one zone IA storage tier as a way of maintaining some variation copy, usually a smaller version or perhaps a lower resolution. Glacier Deep Archive are actually used for cold permanent storage. Glacier, as the name suggests, is frozen storage. It gives you a significant price reduction in terms of store. However, it comes at the expense of having high latency, high wait times before you actually retrieve the object. Reduced redundancy is not recommended to be used. It's more expensive than any of the other tiers, and it is a storage class that is being deprecated. Moving forward on this particular panel, we get to review the permissions, and we finally get to upload our object. The panel indicates a progress report of the upload until we finally get it accessible. At this point, we see the file being uploaded. We are within the bucket ACF S3 demo, and we get to see the different tabs for the bucket configuration. If we select the actual file, we then get to be able to inspect the idea of the latest version. We left versioning unavailable for this particular bucket as well as this particular object within the bucket. However, you get to see the metadata that is associated with the file. We call S3 object store. And despite the fact that you're actually uploading logical files, they become objects simply because these files get wrapped around with additional metadata like owner, last modified, storage class, whether server-side encryption is enabled or not, and that turns the file into an object. More importantly, also notice the object URL in order for you to be able to access it using an API or using a web browser from anywhere. By virtue of the permissions that we actually use, which are the default permissions, public access to this particular object is actually disabled. The first thing that needs to happen is that we need to enable public access on the bucket. We're going to do that as an exercise, although the best practice is for you to be able to determine who will have access to this and manufacture a bucket policy that will allow access only and exactly as you need to. Public access to S3 resources is frowned upon and usually causes more harm than good. However, for the sake of an exercise and to demonstrate the built-in protections that the system has, let's go through the mechanics of habilitating public access. I'm going to navigate to the bucket that contains the object. And in the particular bucket, I'm going to select the permissions tab. And notice how there's a full set of block public access settings. I'm going to click on the edit menu and then uncheck block public access. Please note when I click on save, the system actually asks me to confirm that this is in fact what I want to do. This is a reminder that updating public access settings will have an impact on the bucket and all of its contents. I use the word confirm and verify that that's in fact what I want to see happen. Now I have enabled public access at the bucket level. So now the blocking of all public access has been disabled. I can navigate back to the overview tab. I can select the file, and then on the actions, I can select make public. The system reminds me that everyone will have access to this particular file, and I confirm. At this point, I will expect to be able to navigate back into examining the file metadata. And when clicking the item, I will expect a download dialog to permit me now to be able to download the file. There's a significant amount of other features that are worth exploring with S3, especially when it comes to properties. The idea of versioning, the idea of server access logging. You can use an S3 bucket to be able to host a static website. A static website is a website where no dynamic information is generated. This could be just static HTML pages, JPEGs, even perhaps videos or pictures. And it does not require for you to manage a web server or anything of the sort. It scales up and down as needed and can be easily configured. In terms of management, there are a number of other properties that you can set up. Notice default encryption, as well as things like events, where the S3 bucket will generate an event, perhaps to activate a Lambda function when an object is actually uploaded, and the idea of who pays when a particular object is associated. This is more an introductory demo for Simple Storage Service. I hope you found it useful, and thanks for watching.
Welcome. This video covers Amazon Elastic File System, or Amazon EFS. Amazon EFS implements storage for EC2 instances that multiple virtual machines can access at the same time. It is implemented as a shared file system that uses the network file system. Amazon EFS is a fully managed service that makes it easy to set up and scale file storage in the AWS cloud. You can use Amazon EFS to build a file system for big data and analytics, media processing workflows, content management, web serving, and home directories. You can create file systems that are accessible to Amazon EC2 instances through a file system interface. These file systems support full file system access semantics, such as strong consistency and file locking. Amazon EFS file systems can automatically scale from gigabytes to petabytes of data without the need to provision storage. Thousands of Amazon EC2 instances can access an Amazon EFS file system at the same time. And Amazon EFS provides consistent performance to each Amazon EC2 instance. Amazon EFS is also highly durable and highly available. There are no minimum fee or setup costs for Amazon EFS. You only pay for the storage that you use. Think of Amazon EFS as file storage in the cloud. With Amazon EFS, you can create a file system, mount the file system on an Amazon EC2 instance, and then read and write data to and from your file system. You can mount an Amazon EFS file system in your VPC. Amazon EFS supports Network File System, or NFS, versions 4.0 and 4.1. You can access your Amazon EFS file system concurrently from multiple Amazon EC2 instances in your VPC. So applications that scale beyond a single connection can access a file system. Amazon EC2 instances that run in multiple availability zones within the same AWS region can access the file system so many users can access and share a common data source. In the diagram, the VPC has 3 availability zones, and each availability zone has one mount target that was created in it. We recommend that you access the file system from a mount target within the same availability zone. One of the availability zones has 2 subnets. However, a mount target is created in only one of the subnets. There are 5 steps to set up your Amazon EFS file system. First, you need to create your Amazon EC2 resources and launch your instance. Second, you create your Amazon EFS file system. Then you will create your mount targets in the appropriate subnets. Next, you connect to your Amazon EC2 instance and mount the Amazon EFS file system. Finally, clean up your resources and protect your AWS account. In Amazon EFS, a file system is the primary resource. Each file system has properties such as ID, creation token, creation time, and file system size. Mount targets also have properties such as the mount target ID, the subnet ID for the subnet where it was created, and the file system ID for the file system where it was created. To help organize your file systems, you can assign your own metadata to each of your file systems. Each tag is a key value pair. You can think of mount targets and tags as sub-resources that do not exist unless they are associated with a file system. Thanks for watching. We'll see you in the next video.